Welcome back. This is the second in a three-part series looking at the changes I've seen in the design of bathroom ventilation in residential apartments. In the first demonstration, I set up a basic old one-bedroom apartment in CONTAM with a fairly typical exhaust arrangement for a single bathroom that relied on leakage through the facade to replenish the exhaust. I didn't see any real issues, even when I increased the exhaust rate in line with the usual more is better approach adopted in lazy design. Now, building on the model from the last demonstration, I'm going to look at what happens when we add enclosures requiring more exhaust from the apartment and tighten up the leakage through doors and windows in line with what I see as fairly commonplace recent design. I'm going to start this demonstration by altering the plan from the previous demonstration a little. I'm going to add another bedroom here and put in a bathroom or an ensuite and a laundry there. Find these spaces quickly. There are two. Another one at 15 square metres. Ensuite. Say 7 square metres and a laundry here. And 3 square metres. Okay, then we'll add some features, some flow paths. I'll have an external window. I'll have a few internal doors here. Again, I'm using these from a library that I prepared previously. Old window. Open door. Another open door. Another open door on the bathroom, again just for the purpose of modelling, and we better have some leakage through the facade over here as well. Assume that's the only additional external wall, old facade, and we'll say that that's 3 metres long. Okay, we need to add in some of the new exhaust features, so we'll have an exhaust point in the new ensuite here. We'll add another return. We'll say it's 50 litres a second, common number, I'm not saying that's right. And in the laundry as well, put that one up to 80, which again is quite common in modern design, and again it's not necessarily right. Okay, now we can run the simulation. Okay, so having a bit of a look around, again we've got some air coming through around the door. We've got the balcony door, we've got air leaking through windows, and we've got air leaking through the facade of the building. Now we can see that the space here is about, it's just over 12 pascals below the ambient. So the pressure drop across the facade is just slightly over 12 pascals. But I'm still using some cheap old doors and windows, so let's tighten those up to a newer spec. We'll go to the front door and we'll change it now to a newer door with a weather strip on it. We'll go to the windows, go to a newer window. 1, 2, and 3. So replace that balcony door, one with some slightly better seals on it. Say okay, and we'll run the simulation again. We'll close that, and we'll see, looking across the balcony door here or in the zone itself, we see we're at about 30 pascals. Now that's too high. The occupants are likely to notice some whistling around some doors and a drop in performance of the exhaust systems due to the change in what the fans see. Eventually the occupants might work out that the problems go away when they leave one of their windows slightly open. So I'll test that. Let's just pick this window. I'm going to change it to a window that's left open, slid open 50 mil. Run that again and have a look. Okay, so now we're back down to 3.5 to 4 pascals, so it's probably okay, but let's hope the occupants were told they need to leave that window open for the design to actually work. Okay, thanks again for watching. In the next part of this series, I'll have a look at how the facade construction, based on JV4 in NCC 2019, puts more responsibility on the designer of the exhaust system to coordinate a deliberate source of makeup air. Thanks again for watching.